I'm Mike Mann, the technology director at Data Machines. I gave a short version of this talk yesterday, so I don't recognize anybody, but there's a shorter version online. If you end up needing to go, it's already up. But I'm going to give this one. I'm going to leave some time at the end for questions because, as I'm about to explain, we've deployed quite a few clouds. We support some interesting workloads. And if you have sort of generic questions that could be about what I've talked about, or maybe some OpenStack ones in general, if I know, I'll try and give you an answer for. So this is a little bit about me. As babyface as I am, I've done quite a few cloud deployments. 4 of them are currently running in active production in the US government. And I have 6 of them running that are supporting and running active DARPA programs. My background is in cybersecurity. I'm sort of transitioning a little bit more towards HPC systems engineer right now, but that's just based on my current workload. So when people ask me what my title is, I never know. So today I said HPC systems engineer. We'll go with that. And I'll go with pseudo HPC. I've been a stacker since 2013, and that's the year of my first successful OpenStack deployment. I was interested in 2012 on a personal level, but I was not successful in deploying it back then, but it was a different beast back then as well. So we have, at Data Machines, we're supporting 10 active R&D programs. This is where we make most of our money, is government contracting. So I'm not here to sell you anything. So we're about to find out. We actually try and deploy a lot of open source. And that's really important to us because we grab from the upstream for almost everything. We really don't want to pull something or rely on something that eventually one of our customers is going to have to pay for, because that customer right now is mostly the US government. We pay taxes in the US, and technically I pay myself with my own taxes, is how I like to look at it, make me feel a little bit better. So when we're actually running these deployments, when we're making changes and we're adding things to it, when we're cherry picking, we do it from the upstream. And that's not just with OpenStack. We do it for Mesos and Kubernetes as well. And then a small note that we do burst into public clouds if necessary. Right now, we pretty much just do AWS, but that's kind of just a choice because of our customer. But and then across all of our clouds, we have a fairly drastic and diverse set of research goals, but they're data science and data analytic heavy. And that's mostly so you know what kind of workloads we're running. And there's the typical icon slide. This has evolved some. I'm sure you can see where we've pulled some of these, changed some of these in recent times. Ceph is fairly new in terms of what we'd actually put into the cloud. And I can talk about these in some more depth, especially depending on questions that are going on. The only one on there that I'm going to put a huge asterisk by is Confluence. I told you we do open source. The government really likes Confluence. So they ask us to buy Confluence and put it on the cloud so the researchers can collaborate. So we don't say no. But that's really the only thing. In fact, most of Confluence's functionality nowadays could technically be duplicated in GitLab. I love GitLab, by the way. It's fantastic. So banana for scale. Here is one of the clusters. I'm not going to read all of that out to you, but I will leave it up here for a second. This is provisioned across 2 racks. It's rather simple. This is really straightforward. There's nothing crazy here. I can tell you that those Pascal GPUs are just Titan XPs. So they're actually consumer-grade cards. They're not professional-grade P-series cards. Also an interesting story behind those. We have some code that turns over KVM to basically fake those GPUs and letting them be virtualized through PCI pass-through. We have both a bare metal Mesos and then OpenStack sitting on bare metal, and the 2 clusters run simultaneously. And then the Mesos cluster is actually able to burst into OpenStack, which is really nice because one of the special things that we also take care of is because program needs and research needs and all of this evolves really quickly, we can't build one cloud and stick a program with it. We have to build that cloud and then iterate on that cloud and then potentially turn that cloud into something else. So this program and this cluster was OpenStack heavy at the beginning, and starting next month, we're going to basically be transitioning almost all the workload over to Mesos. We're going to leave a little bit of OpenStack because what OpenStack is doing is it's enabling development on full VMs in a remote workstation style for researchers who don't necessarily have access to regular development devices, or maybe their university-provided laptops kind of old. So what we give them the ability is develop locally to at least some set of resources. And this is the same set of resources that their work is eventually judged on, evaluated on, and tested on, and then run in production on, depending on what it's going for. And we have to always be certain that style, that availability is always there for them. So that's why we're going to leave that little piece. And then we help them turn some of their development efforts into a production style deployment, which, okay, now we're starting to get into the talk of what does that really mean. So active research and development is going on. You're creating POCs, you're creating MVPs, you're throwing things out, you're totally washing away what you had done, you're starting over. You need to see how something runs, you need to throw millions of data sets through it, et cetera, et cetera. That works great until it really is millions and millions and millions of individual files, or we're talking terabytes, if not petabytes of data processing that's happening. We need to pull these into a system that is not only reliable, but something we can audit, something we can track, something that can be delivered to the government. Because remember, this is research that's going on. And DARPA is a government agency, and they expect some sort of top to bottom tracking of the products that are pushed through, that are evaluated. So we have to eventually help researchers who are not necessarily good about thinking about what production looks like get something into a production sense. And I'll go into this also a little bit more, but the pipelines that we help introduce will also introduce some sort of automation where they aren't having to do a lot of the normal things of promotion. That's done for them. So we should have hit this earlier, but yeah, we're trying to get to this seamless development production experience where research can be done in a way that is basically like them coding for production. It just doesn't feel like it. They can do their normal job, and technically on the back end, we're helping prep them for what they need to do. So to do this, we simultaneously use provision and batch style job support, which is that Mesos sort of style, Slurm, if you've ever heard of Slurm, depending on what your background is. Those style frameworks, along with full VMs, enable us to do this and enable the teams to do this. And then we, on the background, have implemented CI/CD processes to promote their work. So to them, if you have sort of a basic feel of how Git works, and then if you even know how GitLab works, especially some of the newer versions, if you check in code to GitLab with a little bit of setup, you can have that code get automatically run by this GitLab runner. And that runner can do whatever you want it to do. It could just blindly run the code and return true if you really wanted it to. And great, the code ran and it returned true. Whether or not it actually ran, who knows? But we can put that in place, and that's actually pretty much the basics of what we do. We provide every new Teams repository that gets set, they automatically get the CI/CD, and this is now out of the box with the GitLab, which is great because I think more people should do it. But this is something that researchers didn't have to do. It's something that we did on the back end, we control on the back end, and it, especially at the early stages, it doesn't make much of a difference, which is kind of scary and also kind of sucks. But as they get further and further along, and they're reporting back to us, here's what we're using, here are the tools we need, et cetera, this is what I need on my environment. We just start building them into the images that get stood up when these runners run. So now all of a sudden, 2 weeks later, a runner turns on, and it already has the machine learning library that he needed. And it's no longer something that his, let's say, Docker container in this example needs to have inside of it. We can do it and put it on the base image, have a library, and the Docker container can then mount it as a volume. Some of these libraries work that way, some of them don't. But anyway, so I'll let that be that for now, and we'll get a little bit deeper into that as we move on. And the other point I like to make here as well is that layer 2 isolation, which is pretty much by default in any OpenStack guide, we leave on by default. I think that this is very underestimated in terms of how important it is to have this layer 2 isolation even between teams that are really working together. They don't necessarily know sometimes, especially in these research contexts or these really rapid development. So this doesn't have to be research. So you can look at this as POC development or MVP development. The teams are just working. They're doing their own thing. They're standing their own stuff up. If you have layer 2 isolation off the bat, that team, when they're standing stuff up in their tenant and in their project, they can do whatever they want. I mean, realistically, they're not going to mess with anybody else's stuff. We don't have to worry too much about bad actors because we know who's working on the program and we know who they are, and they have to follow a bunch of rules anyway. So we don't really have to worry about somebody from the public coming in and trying to do something really bad. So I guess we're lucky there. But at least here, if somebody's standing up MySQL, right, or Redis or anything, it's served up in their own area. They can access it. Their team can access it by default, and no one really notices that every other team has MySQL and Redis stood up next to it. And then we work with the teams then to expose those, and we'll talk about that later. So some of the things that this is semi-lessons learned, talk about these, and these are very different for everybody, but we found this to be kind of big. I think 8 times for CPU over-provisioning is now a default. It used to be 16x, so when I first started doing OpenStack, it was like 16x. That is a ridiculous number of over-provisioning in my mind. So we make a rule that it's never greater than 8x, especially because one, that can get out of hand. That's a lot of VMs, just a lot of random overhead. What we're trying to prevent, and what the reason I still talk about over-provisioning is even on our cluster, which is a lot of development, but like I said, we do this bursting from a batch job queue pretty much, which I said is Mesos, but we have some Slurm in there. Those are HPC level constructs and systems that we really do want to be running, and we're not truly running them in an HPC fashion because those true HPC clusters are local to universities, and those need to have sort of a different build, and they're not quite as generic yet. Actually, we just got out, a few people here, we just got out of an HPC on OpenStack Talk because it is a very open discussion right now as to how to do true HPC with OpenStack running as much support as possible, but OpenStack not controlling everything. It's a very fluid discussion. I don't know if does anybody care about HPC? A little bit? Yeah, wow, okay. And so we just got out of this talk, and it was it ended up being a lot of brainstorming, actually, for topics we want to bring up, because we had everybody in the room. But, we, by default, for example, these nodes are not NUMA enabled. We don't, while they're NUMA capable, we don't actually put the NUMA scheduler into OpenStack, and we don't do any pinning, because some researchers in our environments and some of the users don't understand how that works. So if we were to offer it to them, they might use it and they'd just use it by accident, which would probably be the worst case because then they're technically taking away that pinning capability in a performance-based VM from somebody else, because what if somebody in their team knew how to use it but they didn't anyway? We are taking in and out nodes and reconfiguring those nodes for dynamic payloads for people like, we need to run this set of jobs on a pinned infrastructure for X amount of time. Great. I'll evacuate a node of all the VMs, and we'll take it out. We'll reconfigure it for NUMA. It doesn't take very long because Ansible. And we'll put it back in, and they can then use it. And we'll give that node with host aggregate groups, this is host aggregate groups and evacuation of nodes, by the way, are built in OpenStack now. I think Liberty was, where full evacuation of a node was like a single click. Maybe I missed the version by one. It's right around there, I think. It used to kind of be a hand jam thing. Then I think now there's a button in Horizon that says evacuate this node. makes it really easy. We do the same thing with the center volumes if we're serving up any on that node. And then we can bring it in and out. And what you're doing is you're turning off the service. You're saying, OK, hey, Nova, don't schedule anything in this box. So you're not making any drastic changes. You're not editing the database. You're not. I used to actually be totally freaked out by this, because my first successful deployment was Havana. And oh my goodness, if taking a node out of Havana was, I don't think I would have survived. I think they would have shot me for breaking the program. I don't see that have working at all. That system, I felt, if the moment it noticed the node was gone, it might have destroyed all the VMs anyway. So it's really nice that I can report success in the fact that you're following even these just basic Horizon commands. These are all available as an admin in Horizon. So as a cloud operator, I can basically deprovision an entire node from Horizon, which is insane, but really neat. And it shows the level of confidence that OpenStack is at now. And then all I need to do is turn that box into my own personal playground for a second, enable whatever I need, put a new config on it, and that's mostly Nova configs, or actually it's mostly a Nova config. But I have that all Ansibleized, and you just push it out. And then you can re-enable the services on it, and now all of a sudden you're back to functional. And I throw it into a host aggregate group, which is another built-in to OpenStack. If you're not using it, I highly recommend at least looking into it. To say that that's now a performance box, and that box I then give flavors to that are very specific to that host aggregate. Great. Now I can give that to that one team. They have access to a certain set of flavors that are relevant to NUMA, because, oh, by the way, if you're familiar with NUMA, there's a little bit of configuration, a little bit of thought, a little bit of layout based on the topology of the box. It has to be known and therefore configured. And I can give it to that team. They can use it as they see fit. I pass that information on, hoping that they truly understand what NUMA is. If they don't, we work with them. But all of that works. When they're done with it, I can do the same exact process in reverse, bring it back in OpenStack. It's widely available to the cluster again. Yay, this is all super simple, right? It sounds super simple. I'm making it super simple. I was really happy to report it was. And that's very different from definitely some of the other experience I had. I can tell you I tried taking a box out of Havana, and it sucked. It worked, it did work, but I definitely broke somebody's VM because it didn't actually migrate, and it said it migrated, and it didn't migrate. Anyway, the idea, I've totally digressed off this PowerPoint slide, whatever. Who cares? Join me on my trip. It's late, I'm tired, whatever. It's recording. It is. Hi. The idea for us in general is CPU no-ops are our enemy too. The baseline box needs a certain amount of resources to operate, but otherwise I consider it, I pretty much consider these boxes to be, I want to eliminate as many no-ops as possible. And that's why we're doing the over-provisioning. And then when somebody needs it, we're removing that over-provisioning. We're doing NUMA, right? A certain box is targeted for that person. Which sounds like a lot of work to support a single team's needs, but for us, that's actually not that common. And when somebody does need it, they pretty much have to provide us a good reason. And most of the time, it is a good reason, because the people who are asking for that truly know what the impact could possibly be. And then the limits continued here. We never over-provision our RAM because I have never tried to actually see what a box would do if it gave overlapping RAM to 2 VMs. I can't imagine that's good. That sounds like a bad idea. For all of our use cases, it's a terrible idea. Even if there are 100 VMs on a box and only technically 2 conflict and they both crash or something, it would still be bad. 2 people would get pissed, or maybe just 1 person, whatever. It just seems like a bad idea. We definitely follow the cadence of never over-provision RAM. So I make it as a recommendation. I'm making it here. Take it or leave it as it is. I'll leave that up to you, especially in a research-based environment, especially one where you're trying to push towards a production-like state. Doing that is just, it doesn't make a lot of logical sense. In fact, it doesn't really make sense at all. GPUs for us are painfully special. I've kind of already talked about this a bit, and it is obvious, but it's important. we have GPUs that are in OpenStack for their development purposes. We have GPUs in a batch stage style job queue. They use them. They hang on to them as long as they can. We had somebody actually write a batch job that was designed to hang because then he could go kill that. Like he tried to go get that removed from the queue a few days later because he had already readied up the code, but he wanted to make sure he had his GPU. And so he was trying to mess with our batch job. I'm like, come on, dude. Like you could have just like said something. I don't know, made sure it was ready for you. Like I understand you have a time crunch. Nope, he decided that was better. Jerk. Anyway, we have some code, which I say we have some code, and I guess this is a good time to plug, but github.com/datamachines. We open source whatever we can. Some of it is, and you can go now, some of it's very random. My partner just released something that Jim pointed out. It's called food, and I was like, I don't even know what that is. And we opened up the code, and it's like 10 lines of Python to tell us where the nearest food truck is near DARPA. Whatever, and we open sourced it because here you go. Coming to DARPA, food truck. Food.py, you're welcome. Anyway, I have no guarantees whether it actually works, by the way. We just looked at the code. Yeah, I would hope you put a true config file in there or whatever. But we do have some interesting stuff in there, and I'm going to get to some of the software we have later that's not quite on there, but we're definitely going to push it there, and that's some really useful software. I'll talk about when we get there. We can talk more about what's on there. Some of this, what I was going to hit up, though, with the GitHub is we do have quite a bit of Ansible we write by hand, and it's a very special case for this, what we think is important for research clouds. One of them is sort of our generic way, taken from internet tutorials, but at least we Ansiblized it and did our own changes to it, to get GPUs, consumer GPUs, to work in KVM. We didn't need something that was crazy awesome. In fact, there was a talk today about getting consumer GPUs working in OpenStack, and they had some really neat stuff. There was, I think that there's a Nova extra spec now that says KVM disable, basically. And that'll remove the KVM signature from the VM. Sounds interesting. I need to see what they're actually doing when they disable KVM from the inside, where that actually removes the KVM module performance. But anyway, there's at least some cool stuff going on now. So I told you that we have all these CI/CD processes, and it's all automatic, and yay, you researchers use it, and they don't know how they're using it, and that's fine. We use it, and that's big for us. So one of the crazy ideas that is not that crazy, but apparently is, because I wish more people were doing it, and I don't see that they are, is we always, like I said, have to have this baseline that can be reproduced, because at any point a research team needs to be able to build the cloud that we have wherever they want to. So we give them all of the tools, all of the code, all of the versions to do that. And so one of the way OpenStack's really hard to install. So, oh, by the way, we start with Fuel. We're going to be moving away from that because kind of Marantis dropped Fuel. Fuel infra still exists, but it's there. There's still active development. I think it's falling behind in terms of the quality. You definitely have to wait a few releases to get the point release to be stable. Anyway, that's more of a sad thing, as you can tell. But it's a really good place to start, because at least I can point to somebody and I give them the ISO that I have, so I save that ISO. And it's a web UI. I don't need somebody to have a crazy amount of experience with what they're doing. And I can give them a base flat network to install. They can get a pretty basic OpenStack up and running. We've had a few people ask, and they've gotten up and running pretty fast. They've had their struggles because OpenStack networking sucks. But and then we Ansiblize all of the customizations that we do. So like I said, that GPU code, all of the changes we make to Glance. One of the things that we do specifically is we disable Swift, because we have Ceph installed outside of OpenStack. I don't think we have a single cloud that has Ceph installed with OpenStack. We have a whole separate object store that is Ceph, and we don't want them using Swift, and so we want them. We use all the normal Swift space, and we just give it to Cinder for the boxes that were initially having that. So all of these little customizations we capture in Ansible. They get applied to every new box that comes out, and then it's already joined to the cluster, but the moment it comes in, the Ansible hits it, and now it functions how we expect. And then all of it is program public, so while it's not open source to you guys yet, it's per program we make it available to the entire DARPA project, and they can pull it, they can review it, they can contribute to it. So with all the machine libraries or deep learning and machine learning libraries that are coming out, always new versions, et cetera, the teams collectively can get together and say, we want this version. They'll argue about it. We had a recent argument about which version, whether it was going to be Python 2 or Python 3 for the next development cycle, and they were like, we're not going to tell you. You guys have to figure it out. And they did. They fought for a while. The GitLab issue was it's like one of those really ranty GitHub issues for like when Docker changed its name to Moby, kind of like that one. That one just spanned on for days. They did the same thing. It was hilarious. But they picked Python 3. Good for them. Sorry. So yeah, as a cloud administrator, I've hit on this already, but we Ansibilize everything when we can, and we do it right away. And it's really, really important to us that this happens, because I tell my team all the time that any task that you've done more than once or even thought about doing more than once should basically already be automated. You should have already thought about how you're going to automate it. I don't care if it's a bash script. I don't care if it's Ansible. I kind of care if it's Puppet, because I don't really like Puppet, but that's a personal thing. So if you like Puppet, I'm sorry. Your loss. Anyway, it is easier said than done. It has saved us a lot of time. What ends up happening is we get a nice collection of all this random Ansible code, and we promote it sometimes. We actually go, wow, this is actually useful. One of the other DARPA teams goes, wow, that was really useful, or I needed that. I used it on another program. Great. They contributed updates to it. Great. This is awesome. It was free code for everybody. And by doing this, we've also come up with the fact that why wouldn't our OpenStack base images, the ones that are stored in Glance, the ones that every VM is started on, including the ones where Mesos is bursting in, Slurm is bursting in, why don't we build those with code? And we do. So if you've never heard of Packer, I highly recommend reading up on Packer. I've already mentioned the other two, so I'm not going to go deep into those. But if you haven't looked at Packer, here's some Packer code. That's JSON. Well, looky there. That is, with a little bit of redaction, the base Ubuntu image for one of our clouds. And you can see that it runs a playbook. Great. And it has a builder. And that builder is called OpenStack. And then, oh, by the way, that's all the information I had to pass so that Packer could log into our OpenStack, start up a VM, and then it ran the playbook on the VM. When it was successfully done, it gets automatically put into Glance. Done. We can do testing. We can have the Ansible be public. This is the code that has the playbook in it, somewhere in there. It's under the one that says tasks. That's whited out because a little bit of redaction. But the one that says tasks has what's specific to that program, and that gets put into every image. And like everything before, every teammate gets to collaborate on what goes into it. I made executive decisions on a few things, like we have NFS mounts, so I put NFS common. And we have Ceph, so I put the Ceph libraries and stuff in there. So we have some ones that, yay, authoritarian me, got to put on. But the rest of it, the team up. So we have a GPU one, and that's the one I didn't show. That one has a bunch of the libraries, all the versions that people need. We allow them to generate multiple versions. We generate multiple GPU-based images. We have one that's specific for Slurm, but it's all based on one GPU base. And they just work off each other in the Ansible. So that was super easy to set up, by the way. That Packer build to build my OpenStack images took me 30 minutes, except I already knew Packer. So I give anybody in this room who's at least understood what I've said today, I give you it a day, and you'd probably figure it out. And you could have it with GitLab, building images, or just by doing it from your laptop. You could build your OpenStack images with Ansible and Packer. And then it's reviewable, it's easily updatable. So for example, however many times you have to run apt-get update on VMs once they've been started, I tell people, hey, if you haven't done any work, just create a new VM. That runner gets run every time there's code updates, and then it also gets run every night. So we just get the newest app packages every day. And we're pushing forward because we can do that. We're not binding any versions. You can. There are ways to do that. So feel free to do that in your Ansible to bind a specific version if you need it. If we don't need to bind, we let it update. And it works great because the researchers do need to be working on the newest, latest, greatest code because they're going to be transitioning to a DARPA, like a actual government customer later. And we don't know what their requirements are going to be. So most of the time, we have to grab the latest security patch. So we always kind of need to have them working on the latest one because we don't know when that actual cutoff happens. A little detailed, but whatever. So these are two tools that, and they work in tandem. These are two that eventually we're really close on both of them to getting them open sourced. These are available for the users. So they're building all these tools. Great, yay. How do they want to collaborate? For example, there's someone in China who can't VPN into these program networks. They can't see the internal URLs/IPs. How do we collaborate with those teams? We allow the users to actually define their own proxy pass-through. So they can create, that's the one on the left. They drive their own proxy creation. We then publish the URL. We update Route 53 dynamically in AWS, and then it's available on the internet. Except that's bad to just randomly put stuff on the internet. So we throw authentication in front of it. And so the same proxy mapping tool also has this authentication piece, which is actually just an LDAP module attached to Nginx. It's nothing special. You guys could do it on your own if you wanted to, but like I said, we're going to hopefully release this code soon. And the login and username are their normal login and username to their cloud. So any of the teams who have access to these research projects already have access to all of the potential proxied applications that are running inside the cloud. And then we add SSL on top of it. So do you have a question? Yeah. It is TCP. It is a TCP proxy, I think. We don't let the users do TCP without asking us first. I think we go in and make the change. We'll have them update this tool. This tool, like I said, this tool is kind of new. We actually recently kind of really rolled this out. So right now, by default, does HTTP. But there's nothing stopping us from doing TCP. The authentication layer actually takes their username, for example. We accept basic auth. We do let them submit a basic auth to log past this automatically if they wanted to. That sucks. That was our first implementation. So we're looking, like I said, we're trying to actually get this a little bit more secure. So we're looking, we have now an OAuth 2 endpoint. And we're going to try and do OAuth 2 tokens to actually help them get automatically through this if they wanted to automate it. But one of the things we also do is if they wanted to have users log into their system, once you've successfully logged in, your username gets passed through as a header forward through the proxy to whatever the destination is. You don't have to use it, but we pass it anyway. So it also enables them to identify who is logged into whatever web app that they exposed. That's right, where we have the basic for now, and then we're working on the OAuth 2, the token exchange. What kind of pass-through are you looking for? Oh yeah, I mean that'll be probably where we sort of do another token style for the actual TCP communications. Yeah, there's nothing right now per how these programs work. They have to any protocol sharing TCP connections need to be inside the cloud. That's just the way they are. So, any other questions? All right, not too far here. Yeah, this is kind of the last slide. It's the lessons learned slide. So there's stuff there. Most of this is obvious, but I do put it up there because these are the ones at least that bubbled up to me. I'm not going to read through all of them. One of the big ones we've definitely found is the ground truth everything. That's a pain in the butt, and yet it has become so important for everything. Very recently, we have a collection of boxes that we've been having massive issues with. We burned them in. They were fine, and then a few months in, we found a bunch of issues. We're having nodes sort of reboot themselves, which is terrible. That's really bad that a node just click and it's rebooting. Great. Turns out it's a BIOS bug. I took a box out of production to examine that box. It took me at least 60 days to figure out what was wrong with that box because I couldn't ever get it to repeat when I wanted it to. The logs were not great. I put a whole bunch of things on the box to try and capture what it was. I tried to enable, through logging levels through the roof. Never found ever what it was caused. And the only reason I figured it out was because when I called Dell, they went, "Oh, we have a fix in the pipeline." What do you mean you have a fix in the pipeline? They're like, "It's a BIOS thing." Not helpful at all. Yeah, exactly. Regardless, the bug was fixed right before I went on vacation. So it was like October 4th. October 4th is when that BIOS bug the fix for it came out. And I still have yet to actually call an engineer at Dell back to be like, "So, any more details so I can report to the government why their boxes are rebooting and why I have to take a cluster down to update the BIOS?" Anyway, so that's pretty much it. I know I have 2 minutes left. So are there any questions? No? Easy stuff. I'm such a nerd. I love what I do, though. I'm glad you guys let me share my random war stories. That's essentially what this presentation, I guess, turned into. Go ahead.
It's not really a question on this, but you mentioned that you stay up to date with all your
Packages? Yeah.
In the research, do you ever have issues or people concerned about reproducibility where a package could give a different result?
Yep. So I told you that automatically updates. So we also rename the old, whatever was the base image gets renamed. So one, we get this consistency where if you were to just delete the image and put the new one in place, at least on the user's view of Horizon, all of a sudden their image name goes away. It's just gone. Poof. It's blank space. And it freaked them out. Or it freaked them out the first time I did it because that was an accident. But because I was bad coding on a live production system. So we rename them. So they get a bunch of versions. And they always have access to those old versions. So if they're working on something that they need, they can stick with a version. They are being told by the program managers that you need to be trying to push forward. So they might be working on something, and the reproducibility of experiment might actually, so when they're running an analytic on a set of images, and it's based on a certain version of the library, especially with some of these deep learning libraries that are out there, they want to stay on that while they're doing their initial development. And then that's where they're reporting to the actual base image through the program. They all agree on the one that they'll be evaluated on. So the program as a whole has to agree. And they don't always agree. Sometimes we do have to run two. Like, we're not going to force people to use one, but we and the programs like to push people forward because that's what's going to be used down the road. You can't stay legacy forever, and it's a very different mindset. Don't stay legacy. So yeah. Yeah, they can download it, no problem. It's total. We don't, like I said, we don't do anything that's not open source. And if we do have to do something like that, which we haven't, we'd still give them access to it. There would just be some paperwork. Hey, don't release it for, you probably can't release it out in the wild for some reason. But at least you could release it within the university or something. Did you still have a question? So, for example, one of the clouds we have, and I kind of mentioned this at the shorter talk, we have, I'm over now, but we have a larger system that runs sort of everything, all these tiny analytics. The larger system actually runs the analytic. It's collecting all of that information on a per build basis. So they can look at their build, which gets traced back through the GitLab build, which is traced back through. We have all that metadata for even the OS build that it was initially built on, and then when it was transferred to a Docker container, all that is stored in a metadata store. It's Elasticsearch, and they can do full traceback of that if they so feel. All right, I think I'm out of time, so thank you guys. I appreciate it.